Welcome to session 2 of Unit 6. Session 2 deals with the binomial distribution. Binomial distribution. So what we'll be looking forward to at this session? Well, we should know some properties of binomial experiment, study the probability mass function, calculate the expected value and the variance of a binomial distribution. Of course, bi means 2, right? Now let's get deeper. Definition. If a binomial trials can result in a success with probability p and a failure with probability 1 minus p, then the PMF of x is denoted by probability of x such that NP are defined by P of S such NP equal to n combination x, probability of x, probability of p exponent x, multiply probability of 1 minus p exponent n minus x, where x assume values from 0, 1, 2, up to the nth number. You know, as is indicated in the function, nx is the same as n combination x. N combination x. And of course, the expression n combination x, as we all know, will be equal to n factorial over n minus x factorial multiplying the expression x factorial. That is a, so this is, you have a binomial, so you have only two outcomes, either success or failure. So the probability of success will be p, and the other way, the failure will be 1 minus p. For one thing we need to note is that the probability of success does not necessarily mean the event is successful. Success simply will mean in the probability as what we are looking forward to, or the probability of interest is our success at that point. For instance, when we said probability that a seed will not germinate, well, it's not a positive one, but that's our probability of success, because that is what we are interested in. So the probability, the failure will that will be other way around. That's 1 minus p. That's the probability of a seed will germinate. Maybe let's work with an example to get the idea clearer. Example 1. The probability that a certain kind of company will survive a given test is 3/4. Find the probability that exactly 2 of the next 4 components tested survive. So the question again, the probability that a certain kind of component will survive a given test is 3/4. Find the probability that exactly 2 of the next 4 components tested survived. Here we have 2 outcomes. The component surviving is 3/4. So the component not surviving will be 1/4. That's 1 minus success. Now what is the demand of the question? We find the probability that exactly 2. So x in this case is 2. And they said s is 2. And say the components, that the next 4 components tested. So the total number component tested here is what? 4. So in this case, n is 4. So with the probability theorem, they're going to have n combination 2, that is n combination x, multiply the probability of success, that's p. And here p is 3/4 exponent x, and x is 2. And then 1 minus p is 1/4 exponent n minus x. Of course, n is 4 and x is 2. So n minus x is 2. Yes. So when we do the algebra very well, we see that our final answer will be equal to 27 on 128. Quite very simple, right? Let's have another theorem. Theorem 1. That talks about the mean and the variance of a binomial distribution. In a simple sentence, the mean, which is the same as the expected value of a binomial distribution, is just NP. That's n multiplying p. And the variance will be np multiplying 1 minus p. Yes. So if you could take example, referring back to our previous example, while we have the probability to be 3 over 4, our n there was 4. So if we are to find the mean and the variance from that example, remember probability was, the p was 3 over 4, and then the n was 4. So if we are to find the mean and the variance from that, then what will it be? N is 4, x is 2, p is 3 over 4, and 1 minus p is 1 over 4. So the expected value, that is the mean, is equal to np. And n is 4, and the p is 3 over 4. Multiplying them together will give the result to be 3. And then the variance from the distribution will be np multiply 1 minus p, that's 4, multiplying 3 over 4, multiplying 1 over 4. And the result will be 3 over 4 when the algebra is done very well. Very simple. Can you solve the next example from the model? Why don't you give a try? Thank you very much for listening.